Hello everyone. In this video I will show how to model a circular column on top of a square column. Then I will continue with modeling an inclined column. Let's get started. We have a simple 4-floor structure. I will model these corner columns, square columns for the first 2 floors, and as circular columns for the next 2 floors. Let's move on to our top floor. Now we are defining a new column. We call it a new column, and specifically select it as a circular column here. The large R represents the diameter of the circle, while the small R indicates the void inside. First, let's define a 40 centimeters column without any voids. We have defined it. Now, you need to specify the lower level of this column. When we clicked on the column, it automatically took the lower level as floor below. Now, let's examine the 3D model. As you can see, the circular column fits very neatly on top of our square column. If we had made this column 80 centimeters instead of 40 centimeters, the reinforcements in the circular column would not have been able to go downward, meaning it would have been a faulty design. If we had made it 25 centimeters, the beams would not have been able to support it, resulting in a poor design. Therefore, 40 centimeters is suitable for us because the circular column fits perfectly on top of it. This way, we can transfer the circular column modeling to the next floor as well. As you can see, it can be modeled this way. Yes, now let's start with the E-column modeling. We'll tilt the 5x axis to the left. I will model the E-column. There will be a 50 centimeters tilt on each floor for this. I will add 50 centimeters axis. I will add an axis for each floor. This is for my second floor. For my third floor, this will be for my fourth floor. To do this, I will delete all the columns. From the second floor upwards, I am coming to arrange the floor. I am selecting all elements and filtering them. There will be a second floor, third floor, and fourth floor. We will select columns. I removed the beam and slab tags. Now we say, okay, this way. You can select columns. We moved them out of the window this way, and you see, we only selected these, and I say delete. We'll delete them.
Yes, now let's start modeling our columns. From the second floor, we will assign each one as a new column, and they need to be the same dimensions. Our column type is the same. We will change the axis of our column. We are moving our column back because it is on the upper floor. Should it continue to the lower floor? We say no and change the axis of our column here. As you can see, it has become inclined in this way. When we close it, we will continue like this. Now let's move to the upper floor and create a new column again. Our dimensions are the same, but you can change them if you want. We add our column and say no. We move the axis of our column. The lower axis to the previous axis. Let's also do the top floor. We add a new column again, making this one a bit lower for variety. We add our last axis, say no, and change the lower axis from here. Then, we can also define a beam in this way. We can delete these beams and continue with our modeling. Now I will show you the final state of our model. Yes, our model is complete. In this way, you can model your columns as inclined. However, if you are in a high-degree earthquake zone and must use an inclined column, your structure needs to have shear walls and edge shear walls strong enough to withstand earthquake loads. You need to pay attention to this. That's all I have to explain in this video. I wish everyone good luck with their work.